So this is just a quick video on the basics of interval notation. And interval notation is what we will use to describe sets, domains, ranges, and this is something that you will continue to use as you move on into AP Calculus. So we've got three different notations. We've got algebraic notation, graphic notation, and interval notation. Now, everybody is very familiar with algebraic notation and the graphic notation. Now, you can basically go straight from this graphic notation into interval notation, but I'm going to show you a little bit different way to do the graphic. So, if x is strictly greater than 5, now normally what we've done, and let me take just a second and number my handy number line here. Normally what we would do is put an open circle on that 5. But instead of an open circle, since it's strictly greater than, I'm going to use a parenthesis. So basically, the open circle is the same thing as a parenthesis. All right? And the parenthesis does not show inclusion. And then, of course, since it's greater than 5, we would be shading to the right. Now, we can go straight from this graphic notation to interval notation, which would be parenthesis 5 to positive infinity. And notice that infinity is always going to be bound with a parenthesis. So, parentheses do not show inclusion, a bracket does. That's what we're going to see here on the next one. The next one is x is less than or equal to -1. So let's number our number line. And your number line, whenever you're making these, it just needs to be whatever meets your need. So normally we would put the closed or filled circle, but instead of the closed or filled circle, we're going to use a bracket. The bracket shows inclusion. And notice how this parenthesis was opening to the right, this bracket is opening to the left because it is a less than situation. Now we can go straight from the graphic notation to the interval notation. So since left to right, we're starting with negative infinity. We're going to start with negative infinity. And once again, infinity is never bound with a bracket. It is always bound with a parenthesis. Always, always, always. And it goes up to and includes -1. So interval notation uses the parentheses and the brackets. Parenthesis, not inclusive. Brackets, inclusive. Here we have a compound inequality, which is saying that x is bigger than 4 and less than or equal to 6. So this is not going to be, it is an infinite set, but it has defined endpoints. So if we're going to put this on our number line, number your number line, and then we want to be bigger than 4, but not include 4, but less than or equal to 6. And then every number in between. It's still an infinite set because there are infinitely many real numbers that exist between 4 and 6 inclusive. So this graphic notation can go straight to interval notation. So 4, 6 bracket. So not including the 4, do include the 6. Bracket is inclusive, parenthesis is not. Next, we've got an OR situation. So in the previous one, this was also, if you remember from algebra, this was a conjunction where the two sets came to the middle. This is a disjunction where the sets are going to be going in opposite directions. It's an OR situation where this is an AND. And this is going to play out very interesting in the interval notation. So our answers are bigger than -1 or smaller than -3. So get your number line ready. And we want to be bigger than -1 or equal to -1. So bracket on -1 and then shade to the right. But, or I should say, we want to be less than, strictly less than -3, parenthesis opening to the left, and then shade to the left. So since this is an OR situation, It's a disjunction. But think about it. Our solutions exist in one set or the other. In order to show that in interval notation, there's two different shaded regions. So left to right, negative infinity to -3, or the big fat funky U, that's the union sign. The union sign means the same thing as the conjunction or. And then it picks up again at -1 and then goes to positive infinity. We're going to see this union of sets when we have a domain or a range with asymptotic functions and so forth. Lastly, how do we symbolize all real numbers? Well, all real numbers is just the entire number line. So that would be everything to the left and everything to the right. So how do we symbolize that? Well, in interval notation, it's simply negative infinity to positive infinity. Once again, infinity always bound only with parentheses because we will not use a bracket because there is no closure on infinity. So there you go, boys and girls. That's the basics of interval notation.